Hello, I'm Tom, and this is a tutorial on how to make a game in Unity with no experience. And by no experience, I mean you've never written a line of code. So that's one of the things that we will introduce in hopefully the most approachable way I know of. And Unity is a good thing to learn because it is very widely used. It's probably the most commonly used game engine in indie games. It's also used by some quite big teams, so it's both the best thing to learn, I think, if you are going to make your own game, and it's also probably one of the best things to learn if you want to get a job in the industry. It's quite approachable compared to a lot of other game engines. Hopefully this tutorial will make it easier to learn than it otherwise would be. And it's also free. Until you make a certain amount of money, it's free to use, so that's nice. And we're only going to be using free stuff, but nothing in this tutorial will require you to spend anything. So what version of Unity you need and where to get it, I'm going to put in the description, because the information on where to get it might change over time, and I can edit that later. For now, we're just going to create a new project. I'm going to call it NoXP, and make sure that it says 3D here, not 2D. And I'm going to click this button now because it's going to take a while to do. And while that happens, I will say a bit more about what kind of tutorial this is going to be, because I've taken a lot of tutorials and I've bounced off almost all of them for Unity. I've mostly had to learn by just sort of asking friends and Googling things, because I've never found a tutorial that really worked for me. A lot of them were just so overwhelming, they just throw so much at you, it was hard to know where to start. Some of them I found to be very, very slow. It would just take 50 minutes in, we haven't put an object into the game world yet. And I'm like, when do we make a thing? And so that's a key goal of this tutorial, is let's get something working as fast as possible, because that is when you'll know whether game development is for you or not. It's also when learning gets a lot easier, because as soon as you've made something happen, the rest of it gets a lot more self-motivated. If this is for you, if this is something that you enjoy, now you've got some fuel to take you through the difficult parts. Because just having facts thrown at you and information thrown at you, for me, that's the work. That's not the fun part. It's a cost I'm paying for the payoff of eventually being able to make something, have some power and creativity. So we want to get to that point as fast as possible. And at that point, all the other stuff that you get told after that point, I think, is easier to absorb and less of a chore, because it's fueling this other thing that you can that you'll get to have some fun with. We also want to learn as few new concepts as possible. I hate to learn things; it's awful. And in particular, new concepts with programming, that for anything you want to do, there are 100 ways to do it, and there's always a better way than the most straightforward one. There's always a way that's this would be more efficient processor-wise, or you'd actually write fewer lines of code if you got your head around what a callback is, and all this other stuff. I don't want to teach you that. I don't know most of that stuff because I've avoided learning it too. As much as possible, I want to just learn the basic building blocks and then do clever things with those. That means this is not a tutorial to program in the most clean and professional way possible. It's about getting it done. We want to get things done as fast as possible, and with as little just sitting there and trying to understand concepts as possible. And then the other thing that I've had issues with other tutorials that I've taken are I've taken ones where they just tell you to write a line of code, and you write it, and it works, but they didn't tell you why you wrote that or what any of the individual terms mean. And so at that point, it's not that useful, because now all I know how to make is this tutorial project. And if I want to make something else, I don't know where to start, because what do I change here? How can I change this? What else could we have written here? Why did we write what we wrote? So as much as possible, I want to explain why we're writing what we're writing, to the point that you could change what we're writing if you want. If you're going to follow along with this, there's going to be multiple episodes, obviously. You will need to be starting from the same point we are on episode 5 or whatever, but that doesn't mean that you can't mess around with your own project, because I'll also be putting up the source code for every episode. So wherever we end at the end of this episode, I'll zip that up and put it up online somewhere, so you can just download that. That also means if you hit a problem, if you for some reason have trouble following our steps and you don't have the same results, you can just look at this code and see where the difference is. So our new project has been created. We're in Unity. It has a whole bunch of windows. I'm not going to sit here and explain them all in order. We're just going to use them as we need them. The first one I want to talk about is the scene window in the middle here. This is a view of our scene. Games in Unity are made up of scenes. A scene is like a level, really. For now, this one scene is our entire game world, and it probably will be for a while. If you hold right mouse button in this window, you can look around by moving the mouse, and also use WASD the same way you can in a first-person shooter. And as we zoom around this world, we might notice there's only two things in it. There's a camera and there's a light. There is nothing for the light to illuminate, and there's nothing for the camera to see. If we click on the camera, it'll give us a little preview there. You don't really need to look at that usually, because you can just click on this game tab up here, and that is what the player will see when they start the game. And they're going to see almost nothing. There is really not much going on here. So we should create something. We should make an object. So over here on the left, this tab is called Hierarchy. This is a list of everything that's in the scene. So you can see it's just camera and light. We would like there to be something else in this scene. So let's go to Game Object. All these things are game objects. The camera is a game object, the light is a game object, and we're going to go to Game Object 3D Object, and then Cube. And that will create a cube somewhere in the game world. So we can zoom around this, and this, it's created it. So over here on the right hand side, because we've selected this cube, you can click over here if you haven't. This Inspector tab here is a whole load of information about what's on this cube, what it does. The cube is a game object. Each of these things that it's listing, transform, mesh filter, mesh renderer, box collider, all these things, they're all components. And the one we're more interested in at the moment is just transform. Transform is a component everything has, and it's just a blanket term for position, rotation, and scale. That's all it is. It's just those three things. And the one we're interested in right now is position. So it's given its position of just these weird arbitrary coordinates. Let's overwrite those and just say 0, 0, 0. And you will have noticed that thing moves in 3D space. This object is going to be our ground. So we just want like a floor for things to take place on. And so as a ground object, it's a little bit small. It's a little bit small in 2 dimensions. It's fine, I think, height-wise. We don't care how thick it is. But we want it to extend in 2 of these coordinates. So we've changed its position now, and in fact, if you want to just play around with this, you can grab these arrows, you can click on these and drag to move them in a certain axis. And I just clicked on the red one there, and notice as I drag it on the right-hand side there, the x coordinate changes. And there's this little guide in the top right that says, this red thing is x, and the blue thing is z, and the green thing is y. So the 2 horizontal coordinates here, x and z, these are the ones that we probably want to make it bigger in those dimensions. So when we go down to scale here, I'm going to reset this back to 0, because we're just 0, 0, 0 is kind of the center of your game world. It doesn't have any special significance beyond that, just a convenient place to start. We want to increase the scale of this thing, but only in 2 of these dimensions. And x and z are the horizontal ones, so if you type in 20 there, and then we leave y as it is, because the height is fine, and then 20 in z, now we've made a big flat thing. So we did that because x and z are these 2 dimensions, and we want it to be bigger in those dimensions. So that is our ground. The next problem with it, I would say, is that it's very bright. It's really very bright, and if we create another object on top of that to be our player, it's going to be hard to see it. So what an object looks like, kind of its color and its texture and all that stuff, is determined by a material. And at the bottom of the list of components on our cube, there's this thing called default material. We can expand that to see some details on it, but we can't do anything with it. It's all grayed out. The reason for that is we haven't actually given this a material. It's just kind of come with a default fallback thing. Really, for everything in your world that you want the player to see, you're going to create a material for it. So let's do that. We are not going to... The way we would create a material is down here in this project view. So the hierarchy on the left is a list of everything that's in the scene. The scene, like I said, is like a level. It's one particular space. And down here is a list of everything that's in our project. And right now there's just a folder, and it's called Scenes. If you go into there, you'll find Sample Scene. That is the one we're editing right now. You see Sample Scene up there. It says Sample Scene down here. That's the only thing in our project, and the scene contains all this other stuff. If we deleted that scene, we'd lose everything. So let's not. But just here in the root folder, outside of that scenes folder, we're going to right-click anywhere in some empty space and say Create, and then go to Material. And let's call this Ground Material. I've made it all one word. It doesn't have to be. You can put spaces in there if you like. Now that we've done that, this view we're seeing in the inspector, we've selected this thing up, this material in our project folder. It's got all those same details that we saw on the cube, but now we can edit them. And the main one we care about is this color picker thing. It's called albedo. I wasn't familiar with that term outside of game development, but it seems to mean just color, basically, for our purposes at least. And I'm just going to pick a dull kind of blue-gray, because that's my favorite color. And our main goal is we want it to be like less overwhelming, just have it fade into the background. You can make it green or brown. Every time I try and do that, it looks so lurid. I don't have a very artistic mind for colors, so I'm sticking with what I know, which is dark grey blue. Nothing's happened though. Our thing is still white because we've created this material for things to refer to, but nothing refers to it yet. Nothing in our scene knows about this. We just create, like, this exists, but we haven't applied it. So let's go back to our cube, and now we're going to I'm going to scroll all the way to the bottom of this inspector, and then I'm going to drag the material from the project folder onto our cube. Now, for some reason you can't drag it on top of the material that's there to replace it. That would seem logical to me, but you can't do that. You have to drag it below that. So right at the bottom there's just some empty space below the words add component. You've got to drag it to there, and that'll apply it. There are other ways to assign materials, but that's generally how I do it. So now our ground is blue, which is a little bit easier on the eye, and more importantly, when we create our next object, we'll be able to see it. So let's do that now. Game object, 3D object, cube. We've created a cube, we can't see it because it's actually gone beneath the ground. You can drag it around with these arrows, or you could just, over here in the inspector, we can just enter 0, 0, 0. If we do that, it's going to be inside the ground, because the ground is also at 0, 0, 0, and this is the same height. So let's just change its y-coordinate to 1, so it's on top of the ground rather than inside it. And this thing is going to be our player. Oh yeah, so up here in this little name box, we can write that word player, and actually with our ground object, we should have written ground in there. Now that we have two, we kind of need to call them something so we know which is which. So we are already at the stage where we need to write some code, or we want to, because our game, if I was a games critic, I would say that this lacks some element of interactivity. It's a little bit static at the moment. In fact, we can click play right now. If you click play at any time, you can just play the game as it stands, and we're going to find it's a lot like the preview of the game mode, in that nothing happens, and you can't move around, and nothing's going to happen unless we say what should happen. So on this player object, we want to go down to the bottom of the inspector again, and those words add component that we noticed before, just click that now. And all the components you can add, there's a whole load, but right at the bottom of that list is just new script. And we're going to create a script called player behavior. So a script is a piece of code, and it's a piece of code that you attach to a game object. A game object, you can forget the word game, it's just an object, it's just a thing in the world. Because we want our player to have some behavior, we have added a thing called player behavior. It gets added above the material, actually, so that's where it ends up in the inspector. And in order to make this do anything, we're going to have to edit it, and so that means double-clicking the word player behavior here. And that will open Visual Studio. Visual Studio is a code editor by Microsoft, and surprisingly, for a thing by Microsoft, it's really good and nice and helpful, and it's widely regarded as one of the best code editors there is, which was a shock to me when I learned this. But yeah, I've been using it for ages, and it's actually nice. It will try to help you to write the right thing, which is unusual in my experience with software in general, actually. So when you create a new script, it comes with a bunch of stuff already written. Currently, none of this does anything if we just ran it. Well, in fact, we did just run it, and nothing happened. There are a lot of this I'm not going to explain because you don't need to know what it means or why it's there, but the key thing here is there's two functions here. One is called start, and one is called update. And it provides you with these because these are very common things you will need on behaviors, on scripts. You don't have to have them, you can delete them both, and the game would still run. But it's common to want the object to do something on startup, and it's common to want it to do something on update. Update is a thing that runs every frame, and that means if your game is running at 60 frames per second, it will run 60 times a second. But actually, by default in Unity, your game is going to run as fast as it can. And so on one computer it might be running at 200 updates a second, and on my computer it might be running at 20 updates per second. So we don't know how often this is going to run per second, but it will run as much as possible. So the stuff you put in here is things that you kind of want to just always be running, or always be doing, or always be checking. And I want to start with the simplest thing we can write, since this is our first line of code. So eventually our goal with this player behavior is I want you to be able to move around with the WSD keys. We're not going to go straight into that because it's got a lot of components to it, and so I want to explain things as we go. So for now, we are just going to make the player move forwards. Just going to move forwards always. No interactivity, just going to move. So how do you change something's position? To move it, we're going to change its position every update. So we're going to write transform, and as I type the word transform, Visual Studio pops up and it guesses. You probably want to say transform, and I can just press enter and it will auto-complete that. And then I'm going to say dot position. And again, it knows I probably mean position, and I can hit enter to complete that. And now, bear with me here, we're going to write plus equals. That is a symbol for increase it by. And then we're going to write vector 3 dot forward. And right at the end we put a semicolon. Semicolon, you have to end every line of code with that pretty much, with a few exceptions. That is telling the game, okay, this is the whole line of code, we're done, we're not going to add anything else to this. So I am going to explain why we just did that. Transform.position, that is, remember this transform heading, right under that is position. That's what we want to change. Remember, if we want to move this thing, then we want to change its Z coordinate, so we want to change its transform position. So you write transform.position, and that's what we're talking about. Then this plus equals, it's a shorthand thing for saying we're going to add something to this. Take your transform position and add something to it. I always pronounce this as increase by, because that helps me remember that the plus comes first, not the equals. So increase plus equals. And then this term here, vector 3 dot forward, this is if we mouse over forward, it'll actually tell us. This is shorthand for writing vector 3 0 0 1. So if you look back at transform position, this position is a vector. It's a vector 3. It has 3 components to it. A vector is just a bunch of numbers that come together as a set. They also have some meaning in space as well, but we don't need to worry about that exactly right now. For programming purposes, it's just numbers that come together, and a vector 3 is 3 numbers that come together, and your position is a vector 3 because it needs an x, y, and a z. If we're talking about this world, and I'm in this world, and I tell you, hey, I'm at position 1, you would probably say to me, what do you mean? Like 1 what? 1x, 1y, 1z? What are your other coordinates? You need to tell me 3 numbers for me to know where you are in this world. So that's a vector 3. It's when you need 3 numbers all together. And vector 3 dot forward is a vector that is just 0 here, and 1 there. And that's not the position we're going to move to. That's the position we're going to add. We're going to add those numbers on. So basically, what it really means is we're going to add 0 to our x coordinate, 0 to our y coordinate, and 1 to our z coordinate. Put another way, this is just a word that means a bit of movement in the forward direction. And it's written this way. When we say vector 3 dot, I think of this like, this is the vector hotline. What the hell?
East, south, and west, commonly denoted by their...
Google has just started telling me about compass directions. I'm going to move my phone a bit further away from me. I guess I must have... What did I say? Did I say the word Google? No. Anyway. What we did here is basically we called the vector hotline and we said, hey, what would be a vector for just going forwards a bit? Like, vector hotline, tell me what the vector is for forwards. And it's going to give us that back. And that's what we're going to add to our position. So that is our entire line of code. We're done. Now we're going to test it. I hope you could hear my phone just then, otherwise I'm going to sound like a crazy person. So let's play the game. And the cube that was in the center of our vision just flies away. That's what we thought would happen. We thought it would just move in the Z direction. There are several things wrong with this as a game. But I would say one of them is just that we don't really have a good view of what happens there. We can tell that it goes away, but this is not the camera perspective we want. Now this camera, we can click on it and we could like adjust all these values and try and move it around in space like this, or try and drag it to where we want and look at this preview and see if we've got it right. But actually there's a much easier way of doing this, which is as we zoom around in our scene view, which is this fairly familiar kind of FPS controls, just move the camera, move our position to where we want the camera to be, looking, get this view looking how you want the game to look. And then once you've done that, you can click on main camera, go to game object, and there's an option called align with view, which means it puts that object exactly where your view is. And now if we go back to the game tab, it looks just like that. So if we play again, we should get a much better view of this thing shooting off into space for no reason. So we've written a line of code, and it did something in-game, which is cool. I'm just noticing over here in the hierarchy, this little asterisk next to sample scene, that means it isn't saved yet. So let's just hit Control S to save that. It's good to get in the habit of doing that often. So I think the next thing to do is let's make this interactive. Let's make it not always happen, but only happen when you press a key. So on the line above this, we're going to write, I'm actually going to write a comment here. So you see these lines in green, they both start with a double slash. You can write your own ones of those. And that is not processed by the game at all. It's just a note to yourself. It doesn't do anything. So I'm going to write a comment that announces what we're about to do. If the mouse button is clicked, move us forward. So that's a comment. It's not going to do it. Now we need to write some actual code. That's also going to start with the word if. And after the word if, we open some brackets. And now everything in the brackets is what the game is going to check. So we need to write something inside these brackets that says, was the left mouse button clicked? And so in the same way we called the vector hotline to ask it for a vector for some forward motion, now we're going to call the input hotline and ask it, hey, has the left mouse button been pressed? So the word for that is get button down. So, hey, input, tell me if this button was put down and was pressed down. After get button down, we need some opens and brackets, another set of brackets, and in quote marks, we're going to write fire 1. And actually, by the time I've finished writing that, it's already done the close quotes, the close brackets, and the other close brackets, which is nice. So, when we call the input hotline and we ask it, hey, there's a button, I want to know if it's been pushed down, we have to tell it what button we're talking about. And the name for the left mouse button in a standard Unity project when you first create it is fire 1. It's a stupid name. It shouldn't be that. We can eventually change this, and we'll get to that later on, but for now we're just going to work with what we've been given. Fire 1 means the left mouse button. And we are just going to ask the input system, was that pressed? If that was pressed, then we want to do this. And so for that we need to write a brace. So you see here under this update thing, it says, here's the update function, and then it opens a curly brace, and then it closes the curly brace later. Everything in between that is what is going to run every update. So the braces are a way of sort of enclosing a chunk of code and saying this is what we're talking about. So with an if statement, after we said in normal brackets, we're going to say here's what you want to check. Next thing we do is on a new line, open a brace, and it's going to insert a closing brace as well. I generally just delete that and then write my own one after the code. We want it, if that button is being pressed, here's everything we want you to do. All this chunk of code is going to run. It's only one line, so it's actually pretty basic, but if we might later want to write more stuff in here. And so yeah, this bit of code says, if this stuff in the brackets is true, do this stuff. It's just, if this, then that. So we should find now that each time we click, we go forwards a bit. Yes, we click on that game world, and the cube goes forwards each time we press. Just a little bit of a tip here. You can also, instead of get button down, if we just said get button, that will give us a different result. So get button down means, was this button just pushed down, just now, like this update? Is this the first update since the button was pressed down? And so that's why we only move a step every time we click. If you hold the mouse button down, it doesn't do anything. If you just say get button, you're saying this will be true all the time the button is held. And so we should see, if I play again, it takes a long time to switch to Unity. Hold it down, and now it shoots off smoothly. Still not really what we want, but that's somewhat useful. So what we really want is for WASD to do this. We don't want to use the left mouse button. I've started with the left mouse button because that is a button, and WASD are actually a bit different. In Unity, it wants to make it easy for you to have, for example, keyboard controls and gamepad controls. And so it treats WASD as if they're moving a joystick. They count as axes. So W and S is the vertical axis, and A and D the horizontal axis. And so that has a nice consequence of when you come to add gamepad controls to your game, it's kind of already done for you. You just got to plug that in, and your same code that's going to respond to key movements is going to respond to gamepad movements. But that means that for our purposes, we can't just check those as individual buttons. We're going to look at an axis. So instead of saying get button, we're going to say get axis. So get axis, let's do forwards and backwards movement first. So that's the vertical axis. If we say if input.getAxis vertical, so we're calling the input hotline, we're saying, can you tell me what the vertical axis is doing right now? This is an error. This is red underlined because the answer to that question, if we call the input hotline and say, what is the vertical axis doing right now? It's going to come back to us and say 0.7. And if you just say if 0.7, the code understandably doesn't really know what you mean by that. Like if 0.7, is 0.7 true? I don't know. This is a number that's going to vary between -1 and 1. It's going to, if I'm holding back on the joystick or holding S, then it's going to be -1. If I'm holding W, it's going to be +1. So we can't just say if that, because it's a number. It doesn't make any sense to say that. So we could do, just as a step to demonstrate something, I'll just say, if the vertical axis is equal to 1, then let's move forwards. When I wrote equals there, I wrote double equals. You have to do that anytime you're asking a question about whether two things are equal. It's double equals for that. Using a single equals does something different in programming, which we'll cover later. But if you're checking a comparison, this is called, you use double equals. So we're saying, okay, input hotline, the vertical axis, is that 1 right now? If it is, move forwards. And so the actual key configuration for this is already set to some default values in Unity. So now if I hold down W, we shoot off into the ether, I guess. For some reason, the Unity is not maximized. I'm just going to fix that. So that's all right. We could just write a bunch of if statements. We could say if it's equal to -1, then go backwards. But it's a bit cumbersome to do that. And actually, we're losing out on some nice feature of Unity, which is that as you're holding W, the axis doesn't go immediately from 0 to 1. It's actually going to smoothly increase. In fact, I'm going to show you what it's doing, because it will hopefully help sort of illustrate why we're going to do what we do next. So just to show you what the axis is doing, I'm going to write debug.log brackets, and then this whole term, input get axis vertical, I'm just going to select that, copy and paste it, and put it in there. Put it inside those brackets, and semicolon to end the line. So debug, now we're calling the debug hotline and saying, can you just write this down for me? So log just means tell me this. While the game's running, tell me this. The word debug, the reason it's that word is that this is something that we're going to see as the developer. The player is never going to see it. So debug logs, the player will never see them. They're just for us. So we're already telling Unity, look, just all the time, every update, tell me what the vertical axis is doing. And I'm doing this just to illustrate to you what it is doing. So when we play our game, it's going to be telling us this information, but it's going to be telling us it in the console, which is down here in the bottom left. Next to where it says project, there's a tab called console. And you'll see it's spitting out a whole bunch of zeros. The number 0 is just spewing out all the time. But if I hold W, Nothing's going to happen because I haven't clicked back in the game world. This is a good tip. If you've clicked somewhere else in the interface, your game controls aren't going to work until you click back in the game mode again. In fact, you just saw that little blue line appeared there. I guess that probably means that the game window is active and the controls are going to work. So now if I press W, we see a whole bunch of decimals, and now that I'm holding it, it's 1, and when I let go, we'll see a bunch of decimals, and then it goes back to 0. So it's smoothly going between 0 and 1, and if I hold S, we'll see a bunch of decimals, and then it's -1. So that's what the vertical axis is. When you're holding W, it's 1. When you're holding S, it's -1. And in between those, it smooths out that transition. So all of that is to explain why, instead of asking if the axis is equal to something, we're just going to add the axis to your position. The axis is a number between 0 and 1. Instead of any of this if stuff, we can just say, because we're adding this vector on, we can multiply that vector by the axis. Remember, the axis it could be 1, it could be 0, it could be -1, it could be anything in between. And if we just multiply this forward motion by that much, then we'll get the desired effect. Because when you are holding W, we're going to multiply the forward motion by 1, which is what we had before. When you're holding S, we're going to multiply it by -1, which means moving in the opposite direction. And when you're pressing nothing at all, we're going to multiply it by 0, which means it won't change. When this is 0, you are going to be doing position plus this forward motion times 0. The forward motion times 0 is just 0. It just doesn't go anywhere. So yeah, this is maybe a slightly, if you haven't worked with vectors before, it might be slightly weird, but you can multiply a vector by a number. So we're talking, this vector 3.forward is a bit of forward motion. It's this much in this direction. If I tell you to multiply that vector by 0, it's pretty intuitive that, so you just mean it doesn't go anywhere. It just stays where it is. There's no forward motion then. If I told you to multiply that by 2, it's pretty intuitive that you could see, just that, but twice as far. And if you multiply it by -1, it's that, but in the other direction. I'm trying to explain as much as possible, but I also realize that if you talk for too long just explaining things, that's actually less clear than just f***ing around and making things happen. So now when I hold W, I shoot off in that direction. When I hold S, I come back. We've got motion in 2 different directions. Pretty cool. That actually feels kind of nice. That smoothing that Unity does I have to say, it does feel all right. If you ever make a game where it literally just goes from 1 to -1 on a dime, it feels a lot more crude. So that's kind of nice. Our next step, obviously, we want to do that, but in the horizontal axis. I reckon you could probably figure out how to write that line of code. We're going to start by copying and pasting it. What do you think the first change we need to make is? The vertical thing, we want to ask about the horizontal axis instead. So we're just going to write that. And then we don't want to, it's still our position that we want to change, but we don't want to add forward motion to it. We want to add left and right. So we could write left, or we could write right. Which direction is the correct one? There are lots of little things like this in programming where you know the high-level logic of what you want to do, but should it be 1 or -1? Or should you add this or subtract it? Should you multiply it or divide it? Or should it be this minus this, or it should be that minus this? In all those cases where there's only 2 options, just try it. Just try it. It's not worth sitting there and trying to be logically rigorous about, I've got to know for sure which one of these things is correct. Just write one of them and see if it feels right. And if it's wrong, you'll know about it. If you're talking about something going in the opposite direction to what you want, you'll find out. And as it happens, right is correct. If we'd written left, it would just be this, but it would just the other way around, and it would feel really weird and strange, and you'd know that and just go back and fix it. So now I can move in all dimensions. We've made player movement, and it has a particular feel to it. It's kind of slippery, it's kind of fast, and it's nice to make a thing move. It's kind of the first step to a game. So we've just got a couple more things to do here as we wrap up. One of them is the speed of that is pretty strange. It's probably a bit too fast, and so we can change that. We can just multiply this by, for example, 0.5 5. You think it's the right thing to do? Yeah. Or we could divide it by 2. We're not going to do this. Because if we did that, let's say we want to divide it by 2, and then we'd also have to write divide by 2 here, and then if we test that and it's wrong, we want it to be like a bit less than that. We've got to come back here and change this here, and we've got to change it here. We've got to remember that we've got to change it in 2 different places. A general principle in programming is you don't want to write the same thing in 2 different places, because if you change that thing, you then got to remember to change it in both places, and you'll probably forget. You are going to write, even for a simple game, our code will be big enough that we can't hold it all in our head. We will forget where things are. So wherever possible, you want to keep, you want to make it so you only need to change something in one place. So really, we should be multiplying this thing by speed, a value called speed. So we're going to make a value called speed. We're going to write float speed equals, let's say 2. The values are a bit weird for a reason I'll explain later. So why did we say float? Speed equals 2, I hope that's fairly intuitive. And this is the single equals I referred to earlier. That's why you have to use double equals when you're asking if something is equal to something else. Because when you use single equals, it just makes it happen. If you say speed equals 2, it's like, all right, boss, speed is 2. Whatever you say, I'll do it. So in this case, that is what we want. We want to define speed. We want to say speed is 2. But we say float before it because when you create a new variable, before we say the word speed here, that's never been referenced before. It doesn't exist. We created it. When you create a variable, you have to tell the game what type of variable you're talking about. And in this case, the type is called floating point. It's a floating point number, I guess. Floating point is it's a technical term for how the number is stored. You don't really need to understand it because we're going to use floating point almost always. There's one other kind of number we might need to use, which is called an integer, which is just a whole number. But for our speed, we don't want that to be a whole number. We want it to be a number we can vary to whatever we like. Might want this to be 2.75 or whatever. Anytime you want to have any kind of decimals or smoothly variable number, you call it a float. And that's just something you'll get used to. So we've written float speed equals 2, and then both of these things, we're going to multiply them by the speed. And remember, when you're not pressing anything at all, this whole thing is getting multiplied with 0. So in that case, it doesn't matter what the speed is. We're not adding the speed, we're multiplying it. And if you have a 0 in any kind of multiplication, it's always going to come out to 0. So we now have a speed variable. It's going to be bad. This is not the right figure. 2 is, it was already too fast. Now it's going to be much too fast. Yeah, it's much too fast. I just didn't want to get into like decimals yet, because actually we're about to make another change that is going to make our speed value very different. So there's another problem with our code right now, which is that I said at the start, update runs as many times as it can. And I didn't want to end this lesson without explaining the obvious problem with what we've just written, which is we're saying basically move this far every update that I'm holding the key. Well, your PC might be doing 200 updates a second. Mine's only doing 20 updates a second. Our characters are going to move different speeds, not just seem to move different speeds, not just like the game is smoother for you and jerky for me, but that object in the game logic will actually be traveling further. Like if I was running a race against the AI and you were running a race against the AI, you'd win and I'd lose, both of us just holding W. The game logic will actually be different. So we can't have that. So we actually want to factor in how often update is running. We need to know how long since the last update. That's the figure we can check. So I'm going to make a new variable, and I'm going to call it max distance to move. I've written that with a lowercase first letter, and then every word in the string, it's all one word, and then I use a capital letter for every other one. That's a kind of standard way of writing a variable. You don't have to follow that, but it generally saves a headache if you just do things how everyone does them. It makes life easier. And there's a reason they start with a lowercase letter. It's because these functions always start with an uppercase letter, and so that makes it easier to tell at a glance whether something's a variable or a function. Our max distance to move is going to be speed times, we're going to call the time hotline and ask it for delta time. So delta, if you haven't heard this word in this kind of context, it just means difference. What is the time difference? And so we're calling a time hotline. We're just saying, how long has it been since the last update? And whatever that number is, we're going to multiply our speed by that. So if your thing is running at 100 frames a second, it's going to tell you, how long since the last update? Oh, 0.01. If my thing's running at 10 frames a second, it's going to tell me 0.1. So my speed will be multiplied by a different number to your speed, and that will account for the fact that the two things are running at different speeds. And now that is what we're going to multiply our input by. So the input is going to be at most max distance to move. And that will mean that the game runs roughly the same on my computer than on yours. There's another step we can do to make it even more exact, which we will do in a future lesson, but not just yet. And the first thing we notice is, wow, it's super, super slow now, because the number we just multiplied this by is a really small one. It's going to be, at 30 frames a second, it's going to be 0.0. It's going to be less than 1. And so we've got to change our speed value. But this is actually a good thing, because previously the speed values didn't mean anything. What is 2? I don't know what that means. I don't know how fast the thing is going in game terms. But now that we're multiplying it by the how long since the last update, this has a nice consequence of whatever we write here is going to be the speed in meters per second. Because remember, 1 unit is 1 meter, and updates, when we ask it for delta time, it's going to give us an answer in seconds. It's going to say, 0.1 seconds, 0.001 seconds. And, I mean, you don't really need to understand why this is true, but it works out that whatever you put as your speed here, as long as you're multiplying it by time.delta time, this speed is now in meters per second, which gives you a good frame of reference for, like, if you were making a car or something, you could figure out how fast you'd be moving realistically. Probably by converting meters per second to something else, but still, it's a real world value, and that kind of has some meaning, which is nice. So let's see if 10 feels all right, and then we'll be done if it is. That is all right. That is a lot slower than what we had before, but what we had before was too fast. This is more like feels like game movement. And so I think we are done with the main lesson here. That was just getting something moving. Next time we'll cover shooting, because that's the next ingredient of video games. We're going to make, I should say up front, we're going to make a pretty conventional video game. We're not going to break any paradigms here, because there's a reason a lot of games are like this, and a lot of the conventional wisdom around making games is accumulated over what games normally are. And so it just makes life easier to learn if we just stick with something really obvious and basic and unoriginal, basically. But we will see along the way a whole lot of ways to make it more interesting and to do weird things. And so on that topic, now that the lesson itself is over, you can stop here. That's the whole lesson. But one of the fun things about making games, is you have the power to just tinker and mess around with things and try different things. And like I said at the start, that was one thing I didn't get from some tutorials. I was told how to do it one exact way, and if I wanted to deviate from that, I was on my own, and I hadn't been given the tools, I felt, to do that. So let's actually mess around a bit. This is, like I say, totally optional. You don't need to do this at all, and it won't really relate to anything else we do afterwards. But I just want to show you what the power and the fun of game development is. So, one thing that I was thinking about as I was telling you all this stuff is that really? Oh, let's click on our player. I was telling you about their position, and that's a vector 3. It's 3 numbers altogether. Its scale is also a vector 3. It's 3 numbers altogether. What if these lines changed our scale instead of our position? So when we wanted to access position, we said transform.position, because that's position under the transform heading. We could just change the scale. Let's write the word scale there. It turns out the term for it is actually local scale, but when we write scale, Visual Studio guesses what we're trying to say and suggests that. So what if, in fact, let's just try that. So forward motion is going to change our forward scale, and then the other one is still going to change our position. I don't know what this is going to feel like. Okay, so now I can make myself longer and only move side to side. And in fact, if I keep shrinking myself, I go into myself and out the other side. So negative size is actually positive, just in the other direction. But then size has no direction. So that's an interesting consequence of the universe, I guess. But now let's try if both of them are changing our scale. Then we can actually change our whole shape in a really weird way. And that feels strange. I don't think I've really played anything where WASD is morphing my shape. And this is kind of how game ideas come about. Sometimes whole game concepts, and other times just ideas for like weird, like what if you're cursed and this is how your controls work? Or if you ever played a game where like you can get a debuff, like maybe when you're drunk or something, all the controls work backwards. Stuff like that can definitely come from you just try wiring things up differently, just alter how all this works. We could literally just put -1 at the end of one of these things, and then movement would be in the opposite direction. So what if, that's if we change the scale. What if we also change this, instead of being forward, when we write vector 3 and then dot, it's actually going to come up with a list of all these things we can do. So left is in there, forward is in there. There's one called 1. Vector 3.1 is 1 in all the dimensions. So what if going forwards changes our scale in all dimensions, not just the forward one? That makes us bigger. And backwards makes us smaller. And going too small makes us big again. And if you then go left and right, we're only changing one dimension, so now we can rescale ourselves into a very tall, thin thing, or in fact we can, oh my god, what have we done now? We can make ourselves incredibly wide, and I think there's a way to, oh my god, oh, it kind of makes you nauseous. Now we've made an incredibly thin wall. You can also, at any time, you can switch to scene view and still zoom around the same way you would have normally. And now we've made a kind of weird rescaling sizing game. Oh my god. So actually getting this back to how it started is a semi-interesting challenge. I'm not 100% sure how it... Are we getting there? Oh yeah, okay, that's it. And now we're back to a cube. There's some kind of game mechanic there, like not necessarily a good one, but like imagine a game where you're just shown a weird shape and then you've got to try and match it with those kinds of controls, and then level 2 is just like we change how the whole logic of how controls work again. Now, you know, this one shoots you into space and the other one turns you upside down, and one of them can change your rotation. Rotation is a little bit different. It's not a vector 3 like the others, but you can get a taste of like the kinds of things you can do when you mess around. So I encourage you to do that stuff as you go along. I find that is a lot of the fun of game development. It's just like, but what if I just change this thing? What if I just make this different? What if I just write some nonsense in here? Let's just try something that doesn't make any sense and just see how it feels. Because there's such a big gap between what you write in code and what you experience in the game. Even after doing this for, how many years? 10 years? There's still, every time you try something you've written, it's not what you thought it would be. It's still a surprise, and that's the fun of game development. I encourage you to engage with that as you go along and not stick strictly to all the rules.